Good afternoon, children. From Aspire Gate, NEET and JEE Coaching Center, even for CBSE classes, also we are conducting. It is in Adayar, Chennai. Today, I am going to deal you with one of the properties of the D block elements, that is variable oxidation state. It's an half-an-hour class, so you can listen carefully because, as I've already told you, that from the properties of the D block elements, you can expect the questions in CBSE examinations as well as in your competitive examinations like JEE and NEET as well. Reason based questions will be asked from the properties of D block elements. So we will start with the next property, that is variable oxidation state. Variable oxidation variable oxidation state. Variable oxidation state. When you take this D block elements, these D block elements exhibits variable oxidation state, not a single oxidation state. It exhibits multiple or variable oxidation states. Say for example, let us take 3D series. 3D series, the elements of 3D series. The elements of 3D series are, it starts from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and then we have zinc. So these are the 3D series. See the 3D series atomic number, it starts with 21, then 22, 23, 24, 25, 26, 27, 28, 29, and then 30. Isn't it? Now we will write the possible oxidation states from scandium till zinc we will write. So when you talk about this zinc, scandium, the atomic number of scandium is 21. So what is the electronic configuration? Electronic configuration will be argon 18, 4s2 and 3d1. Am I correct? 18 plus 2, 20, 20, so 21. What all the possible oxidation states then there for scandium? So it can leave, see it can donate 2 electrons. It can donate 2 electrons. If it is going to donate 2 electrons, then what will happen? 3d becomes 1 and 4s becomes 0. Am I correct? Then also it can donate how many electrons? 3 electrons. 3 electrons means, so S and from D, 1 plus 2 electrons, altogether 3 electrons can be donated. See, this is the unique characteristic properties of the D block elements. See, in case of D block elements, for the chemical bond formation or bonding, metallic bond formation, see in D block elements, it results in the formation of metallic bonding. It always forms a metallic bonding. So why it forms a metallic bonding? Because of the unique characteristic feature, that is, only in case of the D block elements, the electrons from S orbital as well as the electrons from the D orbitals, both the electrons from both the orbitals will involve in the bond formation. See, if you take S block elements, if you take the S block elements, only this S orbital, which is called as a valence shell, from the valence shell, the electrons will be donated. The electrons will be getting donated only from the valence shell. So only this, from the S block elements, only the valence shell, which is called as the S orbital or S shell, involved in the bond formation. It donates the electrons. Similarly, in case of the P block elements, if you take this P orbital alone involved in the bond formation, whereas in case of D block elements, S orbital, which is the outermost shell called as a valence shell, and also the d orbital, and also we can call it as what? A d orbital. This d orbital is nothing but penultimate shell. It is also called as keep this in your mind, penultimate shell. Penultimate shell can also be called as the inner shell. This is valence shell is also called as what? Outermost shell. So both the valence shell as well as the penultimate shell, from both the shells the electrons are involved in the bond formation, which is the unique characteristic features of the D block elements. So that is the main reason why the D block elements exhibits variable oxidation state. Okay, first let us write the possible oxidation states, then we go for the reasoning. The points I will write it down, I will be writing it on the board, so then you can understand. So the possible oxidation states for scandium is +2 and +3. Now coming to this titanium. When you talk about this titanium, the atomic number is 22. So nearest noble gas configuration is argon, which becomes 18, and 3D 4s becomes 2 electrons and 3D becomes 2 electrons. So what all the possible oxidation states as in case of titanium is considered is +2 oxidation state can donate 2 electrons. Similarly, it can also donate 3 electrons, and also it can donate 4 electrons, coming to 3D0 and 4s0 oxidation states. These are the three possible oxidation states for titanium. Now coming to this vanadium, the vanadium has atomic number is 23. So nearest noble gas configuration is argon, which is 18. 4s becomes 2 and 3d becomes 3. So what are the possible oxidation states here? It can donate 2 electrons, it can donate 3 electrons, it can donate even 4 electrons, and it can even donate 5 electrons, coming to 0 oxidation states. So these are the 4 possible oxidation states in case of vanadium. Now coming to this chromium, when you talk about this chromium, we know the atomic number of chromium is 24. This chromium alone exhibits anomalous anomalous electronic configuration, anomalous behavior, anomalous electronic configuration. What is this anomalous electronic configuration? So this I would have explained you in the previous class. So the electronic configuration becomes argon 18, 3d, 4s and 3d. So actually 3d becomes 2, sorry, 4s becomes 2 and 3d becomes 4. This is the electronic configuration. Whereas this chromium will not exhibit this electronic configuration. It will not exhibit this electronic configuration, is not possible. In expected configuration is this one, whereas this chromium will not exhibit this configuration. Instead, it exhibits the configuration that is 3d becomes 5 and 4s becomes 1. In order to attain off-filled, stable configuration, for this purpose, the electrons from the higher energy level is getting drifted towards the lower energy orbital. So therefore 3d becomes 5 and 4s becomes 1. This is the electronic configuration. So this is the expected configuration, whereas we are not getting this expected configuration, rather we are getting this anomalous configuration. So that is why I am calling it as the anomalous electronic configuration can be seen in case of chromium. So now the electronic configuration is 3d 5 and 4s 1. Now we will write what are all the possible electronic configurations are there as in case of chromium. We will see. Am I correct what I have written? 4s becomes 2 and 3d 4. That is not the configuration. Instead, we are getting 4s 1 and 3d 5 configuration. So the possible configurations we can write: chromium +1 configuration is possible. It can donate 1 electron. So 3d becomes 5. So now it is stable. So then +2 configuration is possible, +3 is possible, +4 is possible, +5 is possible. To attain 0 configuration, +6 is also possible. Sometimes when you talk about this chromium, instead of attaining this +1, straight away this chromium gets into +2 oxidation state. Sometimes +1 is also possible. I am not telling that +1 is not possible. It is possible. So now +2, +3, +4, +5 and then +6 will be the oxidation states for chromium, possible oxidation states. Now coming to this manganese. Let us see the possible electronic configurations for manganese. That is, atomic number is 25. So the configuration becomes argon 18, 4s 2 and 3d becomes 5. This is the configuration for manganese. So what are the possible electronic configuration for manganese? +2 configuration is there, then +3, then +4, then +5, then +6, and even +7 is also possible, isn't it? +7 is also possible. At last, let me write +1 for chromium. Okay, +7 is also possible. Now coming to this iron, what happens as in case of this iron Fe? So the atomic number is 26. So the configuration, nearest noble gas configuration is argon. Then 4s 2, 3d becomes 6. 3d becomes 6. So that means what is the case? 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5 and 6 electrons. 6 electrons were present. Now we will write what are the possible electronic configurations. So from s orbital it can donate 2 electrons. Am I correct? Then from d orbitals it can donate 3 electrons, and similarly 4 electrons, up to 4 electrons it can donate. Up to 4 electrons there is a possible, because unpaired electrons were present, so 4 electrons it can donate. Now coming to this cobalt, what happens to this cobalt we will write now. As in case of this cobalt, that is, as in case of this cobalt, that is CO 27, that is argon 18, the electronic configuration becomes 3d7 and 4s becomes 2. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6 and 7 electrons. So totally how many electrons were present? Unpaired electrons, 3 electrons were present. Now let us write. So what are all the possible electronic configuration? So from s orbital it can donate 2 electrons. From s it can donate how many electrons? 2 electrons can be donated. And after then how many electrons can be donated? Plus 3 electrons can be donated, isn't it? So 2 electrons can be donated. After 2 electrons it can donate how many electrons? 3 electrons can be donated. So here 3 electrons. Now coming to this nickel, now possible configuration I have written. So when you talk about this nickel, this is 28. So 3d becomes 8 and 4s becomes 2. This is argon 18. So 3d becomes 8 and 4s becomes 2. So how many electrons? 1, 2, 3, 4, 5 electrons. So how many electrons were there in the d orbital? 1, 2, 3, 4, 5, 6, 7 and 8 electrons. Outermost how many electrons were present? The 2 electrons, which is unpaired electrons. So now we will write the possible electronic configuration. So when you talk about this nickel, again +2 configuration is possible, and then +3 configuration is also possible, and then sometimes +4 configuration. Here when you talk about this cobalt, again we can write +2 configuration, and then +3, +4 and then +5 is also possible. +2, +3, +4 and +5. When you talk about here, it can give +5 configurations also is possible. Now coming to this copper, very important as far as copper is concerned. Now see, as far as copper is concerned, what happened? Copper, the atomic number is 29. So argon 18, 3d becomes 9 and 4s becomes 2. This is the expected configuration, but copper will not exhibit this configuration. Again it exhibits what? Anomalous electronic configuration. It exhibits anomalous electronic configuration like chromium. So then what will happen now? The electronic configuration when you take, so what will be the configuration as far as copper is concerned? 3d becomes 10 and 4s becomes 1. This is the original configuration. If that is the case, then what will happen for copper? What will be the configuration? The configuration becomes only one possible configuration, +1 is possible. Sometimes +2 configuration, that's all. Coming to this zinc, what will happen? As in case of zinc, what will happen? Let us see now. As in case of zinc, the atomic number is 30. So the electronic configuration becomes 3d10 and 4s becomes 2. So the only possible configuration for zinc is +2. So this is the possible electronic configuration. So when you see this 3D series, the elements, these elements right from scandium till zinc exhibits variable different oxidation state. When you take this sodium, what is the electronic atomic number? 11. So the possible oxidation state will be only one oxidation state, that is Na plus. When you take this magnesium, atomic number is 12. So the only one possible oxidation state, that is Mg2 plus. This is in case of S block elements. Similarly, in case of P block element, oxygen 2 minus, chlorine minus, nitrogen 3 minus. This is the possible, only one oxidation state is possible, nitrogen, chalcogens, halogens, whatsoever it is, even for the noble gases as well. Whereas in case of the D block elements, there are variable oxidation states. So these are the variable oxidation states. Now you have to understand one thing before I'm getting into the reason why the D block elements exhibits variable oxidation state. Before we are getting into the reason, you have to understand one more thing. So when you compare, when you go along the series from left to right of the periodic table 3D series, you can see there is a gradual increase. You can see there is an increase in variable oxidation state, from scandium to manganese. Am I correct? So there is a gradual increase till manganese, isn't it? Then what will happen? Again from manganese, there is a decrease in the oxidation state from manganese to zinc. This is called as trends in oxidation states of 3D series. This is called as a trends, or otherwise we can call it as anomalous behavior. You can call it as anomalous behavior. Why such behavior is happening? Because of why such anomalous behavior? Why variable oxidation states? Because of presence of unpaired electrons in S and D orbitals. Due to the presence of what? Unpaired electrons. Where does this unpaired electrons are present? Due to the presence of unpaired electrons in S and D orbitals. Now, very important is the reason. What is the reason? Why? This is the question for the examination. Reason why the D block elements exhibits variable oxidation state. Why D block elements exhibits oxidation state. This is the question. Now we will write down the answer for the same. The reasons, we have to write the reason. So when you take the reason, the first and the foremost important reason is both D and S orbitals are involved in bond formation. Both D penultimate shell, already have written. What is this D orbital? D orbital is called as the penultimate shell. What is this S orbital? S orbital is called as the valence shell. Both D and S orbitals, both the D and S orbitals are involved in the bond formation. That means what? That means it can also be written as the electrons from D and S orbitals are involved in the bond formation, or donated or lost, isn't it? Or given or donated for bond formation. One thing. Then the second reason, Why the electrons from both d and s orbital has to be donated? Because again there is a reason for that, because the energy azimuthal quantum number, the energy azimuthal quantum number, or otherwise it can be called as subsidiary quantum number, azimuthal. This also they have asked in your NEET examination, quantum number or subsidiary quantum number explains about the energy level between s, p, d and f orbitals. Okay, so s, p, d, f. So the energy level or energy difference between d and s orbitals are negligible. So that means what? The energy difference between, see, this is nucleus. Say for example, this is d and this is s orbital. This is a penultimate shell, this is a valence shell. Obviously, S should be the outermost shell, isn't it? This is the inner orbital. So the energy difference between this d and s orbitals are more or less negligible, or otherwise it has equal energy. The energy difference is not much pronounced, it is less pronounced. Different terminologies, synonyms. So what you have to understand, the energy difference or the energy level between the d, the inner orbital and the outermost orbital is negligible, is less pronounced. So the energy level is more or less same. So since the energy level between the d and s orbitals are more or less same, so therefore the electrons from s orbital and the electrons from d orbitals, both the orbitals are involved in the bond formation. Hope you can understand. So first point, what did I mention? The both d and s orbitals are involved in metallic bond formation or bond formation, isn't it? That means what? The electrons from both the d orbital and s orbitals are getting contributed, getting donated for the bond formation. How it is possible? Why the electrons from both the s orbital and the d orbital has to be given or has to be contributed? Because the energy difference between the 3d orbital and the 4s orbitals, when you take 3d and 4s orbitals, the energy difference or the energy level is negligible or more or less same. So therefore the electrons from the s orbital as well as the electrons from the d orbitals can be donated. Is it all clear what I am telling? So that's what I have written. The energy level between d and s orbitals are negligible. And one more point here I have given, the trends. What is the trend? Trends means what? If provided, if there is increase in variable oxidation state means from scandium to zinc, there should be gradual increase in the variable oxidation state. But this has not happened here. What happened? Actually, from scandium to manganese, the variable oxidation states increased. Then from manganese to zinc, when you take, the oxidation states decreased. Why it has got increased? Due to the presence of the unpaired increase and decreases, or due to the presence of unpaired electrons. Where unpaired electrons are present? Usually in the d orbitals. Sometimes, as in case of chromium, as in case of copper, the unpaired electrons were present in the s orbital as well. So that is why I have mentioned, that is the trends in the oxidation state of 3d series. The trends means I am calling it as what? Anomalous behavior. How? This is because of presence of unpaired electrons. Where does this unpaired electrons are present? The unpaired electrons are present in the d orbitals, excluding in case of chromium and the copper. When you take, the unpaired electrons were present even in the s orbital as well. Can you understand this one? Variable oxidation state. So manganese exhibits maximum oxidation state, which is present at the middle due to the presence of maximum number of unpaired electrons were present. So that is why manganese, which is present at the middle of the series, exhibits variable maximum number of oxidation states. Why manganese exhibits maximum number of oxidation state being present in the middle of the series, Niketa? What is the answer you should write? That is because the maximum number of unpaired electrons were present in manganese. Maximum number of unpaired electrons were present in manganese. So that is why manganese shows what? Maximum number of oxidation states. When you take this D block elements, usually this osmium exhibits maximum up to +8 oxidation states are possible. It's a 1 mark question. Osmium. So in D block elements, as I've told you, there are how many elements were present? 40 elements. Out of those 40 elements, only this osmium exhibits maximum oxidation state, that is up to +8 oxidation state. When you take this manganese will be exhibiting the oxidation states up to +7 oxidation states. Okay. I hope you can understand this variable oxidation state. Keep following us. The links will be provided in the various channels, as well as you can go to the Haspergate website, and you go to the website and click into the classes, so you can see the various videos of various subjects which will be given, and the videos which we are going to take and teach for you is very important for your CBSE examination, as well as for your competitive examinations. Keeping that perspective in our mind, we have started taking the classes for half an hour, and even 1 minute video solving questions of JEE as well as the NEET also have been dealt, and that also getting posted. You keep watching. If you want further and more classes, you can come in person, or otherwise you can share your details with us for the online classes as well. Okay, wish you all the very best. Thank you very much.